I've been working with SPACECLAIM for over 10 years, and there's a lot of different applications. SPACECLAIM is a multi-purpose modeler. It's a direct editing tool that's really, called Smart 3D. There's all sorts of, tools out there in CAD and CAM, and, the question is SPACECLAIM either of those? And, it's not your traditional CAD tool with a feature tree and constraints and limitations. Those are great for, very detailed design, but it's not always, the right tool for manufacturing. Varieties of file types, native CAD files, assemblies, parts, also generic file types like IGES and STEP, and there's a few other popular ones, or even faceted geometry, whether we're 3D printing or sometimes you just only can receive an STL file and you may want to reverse engineer it or just modify it. So we have tools that work with all types of CAD data, from the native systems, from generic, faceted, all in one interface. So instead of buying all these different programs, you can work with just SPACECLAIM, learning one set of tools for all of these different files. So these are some of the topics that we'll be talking about. This list looks pretty long, but there's actually more that we could try to squeeze in today, but we're going to focus on some of these key topics here. And, just to, cover some of the advantages, SPACECLAIM, was designed for the non-CAD expert. So if you've never used CAD before, you're probably, an excellent candidate to use SPACECLAIM because, you don't need to, have that history tree, that feature tree that, can often make the CAD process really hard to learn. So, I've taught my nephew how to use this, and it's super easy. Schools implement it. Anyone can learn how to use this software, whether you have CAD experience or not. And if you are an advanced CAD user, you're going to, start to realize a lot of time savings, because you'll just see a lot of, waste has been removed from the modeling. And so there's a lot of time saving. So with that, let's go ahead and, take a look at some of the different applications here. We have a few different models loaded up, and we're going to see what kind of things we need to do to get these ready for manufacturing. So here we have an imported model. And you'll notice it's transparent. We can see through it. And also, we're expecting to have a solid body that we can machine, fixture, but, we end up having a bunch of surfaces in the tree. So one of the main things that SPACECLAIM users run into is receiving models that are corrupt. There is some repair that goes on during import, but oftentimes we need, to go ahead and take a look at some of our repair tools. So SPACECLAIM is nicely organized by tabs into different applications. So it's really easy to find the tools that you're looking for. And we want to make this a solid body. So we're going to look at our Solidify group, where we have a series of automated tools which make repairing this very easy. So this first tool is called Stitch. And, essentially a solid body is something with no openings. Everything is nice and connected. And we can see here that, we have a couple faces that aren't attached to the rest of the body, but also just some edges that are not really attached to each other. And this is a common problem, especially with IGES files. So this automated tool finds everything. And with clicking the check mark, in just a few seconds, we have a single solid body and no issues with any of those edges. Sometimes this is the only problem in a model and it'll automatically turn into a solid. But if not, we could take a look at some of our other tools. We have a tool called Missing Faces, which looks for large openings in a model. We have a tool called Gaps, which looks for smaller openings in a model. And, we're able to, use these tools to repair. We have this little opening here. We don't want a new face. We could have it adjust that edge, and then that's nice and clean. Or if we have these larger faces that for some reason have disappeared, or sometimes we might have a corrupt face that we need to delete, we could go ahead and repair that really easily. Now, for toolpath generation, sometimes we may have extra edges on a model, and those aren't always beneficial. This is very common with IGES files. Oftentimes, rounds or holes, rather, are split into two halves. So we have all sorts of automated repair tools like extra edges, which finds edges on the model that just are not necessary, and it can go ahead and remove them, making machining, tweaking, changing the geometry a lot easier. So if there's any edits I need to make to the model, like if there are rounds that are, of the wrong size, I want to make them a nice, clean, standard size, I could go ahead and select them, either drag to change or, simply type in a value and update those. So, we have a model here that has been repaired in just a few minutes, which otherwise we might have to ask the customer to, send a different file, clean it up, or something, or even remodel it. We've often been told is necessary. So, now we might want to go ahead and get it ready for machining. So we might want to create a fixture. So on a model like this, what we could go ahead and do is, set up to create some soft jaws, some sort of a fixture. We can easily go ahead and just sketch out a starting shape, whatever we want that to be, very easy to modify and just rough out really quickly. And you'll notice here that I'm not going to go ahead and throw any dimensions on. I'm not quite sure what size this needs to be yet. I'm just trying to figure that out first. So it's really easy, to create this block. And, I want to combine these into a new design. So I want to essentially subtract one body from the other and then easily remove that interference there. If I just glossed over that really quickly, we have this combine tool, and what's really nice about it, if you're not familiar with how to use any tool, is, we have this status message that coaches me through the tools. So, the thing I'm trying to cut is this object here. So that's my target. Then it asks me to select the thing I want to cut with. And then if I hide that cutter, it's asking me to click a region to remove. So, for advanced users, you can go through the model really quickly. For a new user, it's going to help you understand exactly what the tool is looking for. Now, in looking at this fixture that it's made, it fits in real nice. However, there are some undercuts and, there might be some issues trying to get that in there. So, if I need to make any changes to the model, we have this great tool called Pull. It's the tool that I use to quickly create this block. So whatever modifications I need to make, I can come in here and either, add or remove. I could go ahead and grab this face here and just pull it back and strip that off. And then make any other changes, snapping faces together to, eliminate steps in detail, even pulling this back, and essentially eliminating it. So this pull tool allows me to easily modify. And, I could add a little clearance into one of these pockets here, just grab some faces and either pull, enter in an exact value if I have something in mind. Or pull also allows me to add drafts. So, pulling like I'm doing in a direction is like offsetting, but drafting is like pulling about a face. So if I want to draft this about the bottom face here, it's very easy to set up, and I could either dynamically draft or just type in the exact value that I want. So this pull tool is really versatile in creating and modifying. And one of our other main tools that allows me to easily clean up a model is this tool called Fill. So anytime I have faces that I don't want, I simply select them and fill them in. And now, I've decided on, the design here, and I may want to go back and, change it and make it, an exact size, a standard size, if you will. So even after creating the model, it's very easy to come in, add dimensions to it, and use those dimensions without having any history to change the model. If I know that my standard size here is 20, I could go ahead and have it pull on just that one face, and now it's 20 tall, or maybe I need to, in doing so, I notice that we actually poke through the bottom over here. So undo. Very easy, Control Z, or we have an undo button up here, which is something that not a lot of software has. So whether I want to add or remove, I can also do this by working with multiple faces. So if I want a symmetric change, it's very easy. It's just however I decide to interact with this geometry. It's not history-based, it's user-based. It allows me to design the way I think So that way I can eliminate any extra steps that I don't want to take. There may be different steps that we want to capture, and what I can do in a single interface, a single environment, is copy and then paste the model. I can right click. We use Office shortcuts, so Control C and V. So if you've used Office, you're already an expert. And if I don't want to, change one of these, I could go ahead and lock it down and create, some sort of an assembly structure. I can move it into a component, call this final, and then I can go ahead and lock it down so that one won't change. From here, I might want to start simplifying areas for different operations, get a stock model, figure out how much material I need. So if there's any geometry that I want to either add material to, I could either pull to change, or I can use our fill tool to simply fill that in. If I need to add on so I can clamp, or for, in order to provide a certain surface finish with grinding, I could easily add on the amount of stock I need, either by dragging or typing in exact values. You'll see that there are easy selections like double clicking to grab chains of faces in order to fill in. Or if I need to remove a number of things like rounds, we have this power selection process. It's like a Google search of geometry. I could find all rounds equal to a certain size, equal size or smaller. I can attempt to change them or fill them in and remove them. So now I can just use one of these edges to have something like ball nose end milled in order to follow it, in order to create that geometry. Or, maybe I need to identify the top surface here in order to, rough that out first. So I could either take these different pockets here, easily search for the entire depression that they're part of, and simply fill those in to simplify. Or I can do that to a surface. I can copy and paste the surface. And if I go ahead and hide everything else here, I can use some repair tools to go ahead and fill in those holes and essentially remove any extra edges that I have. So a lot of different ways to extract needed detail from a model. We can extend, the edges of these surfaces out for, different roughing operations. And at the end of the day, this is all contained in, one single interface. And look at some other types of changes that we might want to make. So here we have an assembly, but it's really easy to just isolate a single part, in order to focus on prepping that if we don't need to worry about the other models. If there's any detail we need to remove, it's very easy to box select large groups of faces and then use that magic eraser called fill in order to simplify it. We may need to add instead, part numbers or, something to the design. So if this is part, 342, I could easily, write out a note. And turning this note into 3D text is very simple. All we want to do is project that note onto the face. It's very automated. All we have to do is select it and complete it. And if I go ahead and just hide that note here, you'll notice that we now have that text. And that text is simply faces on the model that we could either pull out to add or pull in to cut. This pull tool is very intelligent, allowing me to, add or remove just by interacting with that model a little bit differently. So, text is often something we want to either, add or remove. And there's a few other things that we might want to, change on a model like this. For example, ribs are often a topic of conversation with a number of customers in terms of modifying them or adding them. For example, we might want to take a rib, make it thicker, make it thinner. Maybe there's too much deflection, or maybe we're trying to reduce material. Or, if we're molding, or in this case, casting it, these walls, are parallel to each other. So I might want to, apply some draft. So we mentioned, draft is part of the pull tool here, and it's very easy to, add draft in one direction or add draft in another. So, now we'll have an easier time separating this out of the mold, or, maybe I want to change the angle of it. So if I just go ahead and put my move tool over on that end, I could choose to rotate it about here, and I could go ahead and rotate it up and provide a little more support on this area here. Now, in adding this rib, we've added material, we've added weight, we've perhaps added cost, and we might want to now try to remove some. So this pull tool has a lot of functionality with both faces and edges. In a minute here, we'll take a look at how we can use the pull tool to create rounds. A lot of models might be missing rounds, but another thing I can do on edges is basically reuse those edges, offset them. We call it copy edge, and create this nice new offset, this new face here. And what I want to do, I want to essentially cut it, straight through the model. So the pull tool here is going to allow me to, add a little bit of coring, reduce the weight, but we still have a lot of strength. And if, we're concerned, with the stability of the structure here, it's really easy to add additional ribs. I could always sketch it out, and we'll talk about sketching in a minute, but I really like to reuse the geometry we have. I like to be able to take an edge, copy it a couple times. If I need to make a cutout, I could do that real quick, or I could just pull it up and add an extra support there. I can take this support, and if I want to change its location, very easy, to move up and through the model. Maybe I want to put it at another angle, so I could go ahead and rotate it to, put it in the right location. Or if I want to make another one, very easy to, pull a copy and then, just essentially blend that all into the model here. So now another thing we often want to add are rounds. And with rounds, a lot of times it's just a matter of, creating those. And, sometimes they, the order may or may not matter. I could add them in one area, either just dragging, or I could type in values. If I have rounds on the model that I want to make it the same size as, I could easily snap them up to and reference those. There's keyboard shortcuts to automate it. Selecting chains of edges is really easy. Here I'm just double clicking, which is a shortcut that is borrowed from Office. So really easy to add the necessary detail to the model for castings, molded parts, even if we're going to machine these. Now, you may know that some models may have some rounds and not have others. And if you've ever, tried rounding a model, you may know that the order you apply them in, often counts. Like if I try to put one round over another, I may not always get the result I want. So sometimes we may actually need to remove the rounds from the model before adding some good ones. So it's very easy to select with double clicking, and this fill tool is just a magic eraser. It goes ahead and gets rid of those for me. So now I can, play around with the size of rounds just by dragging if I'm not quite sure what value is good, and then I could always round that off after the fact. And, this double clicking is often very helpful in making sure a model is properly rounded. You'll notice that when I double clicked here, it only grabbed these, and that means that the tangency ends right here. This is actually a sharp edge. And, this is something we probably want to have rounded. So I could go ahead and pull that out to a nice smooth round and then repeat my double click. And I could see we have the same problem over here. It goes into a sharp. So I could just go ahead, and I know that this is a good size, so we could pull that up there. And now I can go ahead and add that round chain. So just trying to add rounds to a model in SPACECLAIM helps you figure out where there may be round issues. But there's something that I want to show here on the back side. I could add a rib really quick and easily simply by, copying in the edges like I already showed, pulling that out, and the pull tool even has this option called pivot where I can bring this out and, create that rib, and, we're off and running. However, one criticism I've heard for, 10 or so years is that, I'd like to have some history. I'd like to do some operations and change one thing at the beginning and have all those operations update. And, we now have this interface called block recording. For years, we've had Python script recording, which is really useful, but you need a little bit of experience with, Python. And so this block recording is a really nice simplified interface to still use SPACECLAIM like a direct editing tool, but to capture some of those operations and replay them with different values. In conjunction with that, SPACECLAIM now has a sketch solver with sketch constraints. So here I now have this brand new sketch tab, which is on by default. And we now have all these new sketch constraints, which very nicely get automatically added as I go. So if I'm trying to add a rib here, maybe I'll start over here and I'm not exactly sure where I want it to go. So I'm just going to, park it kind of inside the body there. And just to make sure that, we're going to merge nice and cleanly, I could, come into the model over here, or I could, snap right to this edge. I know that we have a nice planar face. So, very easily I could undo, try out different things while I sketch. Now, if I go ahead and I add a dimension, let's say to this line here, you'll notice that it changes from this lighter blue to this darker blue. And if I go ahead and say dimension the angle of these, the same thing. Those colors are representative of the model being defined or constrained. And so, here I could leave this, free and open. Essentially, if I want to see how a model is underdefined or underconstrained, I can start dragging on the sketch. And you'll notice that things that are constrained, I won't be able to drag here. I can't, drag this point because it's actually constrained by this dimension. This here isn't, so I could essentially drag it around. We'll just see that if I go ahead and add a quick dimension to it, that will fully constrain it. What's new about these dimensions, if you've used sketch dimensions in the past, is, these aren't measurements. These are actually constraints. These are values. I can change it and it will update. It knows how to update because of the constraints that are automatically added in the model. So let's go ahead and end this sketch. And for now, I'm just going to, model this as if this wasn't here, as if I were, just doing some direct editing. I might want to pull it symmetrically. I might go ahead and drag it out to a value that looks good. Right now it's a separate body, so I might go ahead and combine them together. And then I might, start adding, some detail. I might want to draft this in so we could release from the mold or casting. I might want to, add a round here. So full rounds are very easy to add. And, just like we saw a minute ago with adding rounds, it's very easy to add either individual rounds or chains of rounds. And now, I essentially have this model. Now, there may be some changes I want to make. So let's see what actually got captured. Things like the dimensions got captured, the amount that I pulled, certain options like pulling symmetric, all of these things that I did got captured here. And so, if I want to make this rib shorter, like if I just want to change that dimension from 6 to 5, I could go ahead, type in a new value and essentially replay it. And we'll see it just moves back like that. One topic that, comes up a lot is draft. And we showed a little bit of drafting on those ribs, but oftentimes we might have a model that we want to take a look at analyzing the draft. So we can measure the draft on a model. We can measure the draft in any particular direction. And essentially, if we have a release direction vertically and up and down here, green is, passing and red is failing. And this is evaluating it based on 0 degrees. So basically, we can see here that there are no undercuts on the top, but basically everything would be an undercut on the bottom. But we might want to look at the model and see, what faces past a degree of draft. So if we change that to 1, we can see there are a few faces here that have 1 degree of draft, but most of the faces, don't pass that. So these essentially have 0. And if we look at anything above 1, we could see none of the sidewalls have draft on the model. So in order to change that, we have a few options. We can draft that with the pull tool, and, we could either do these, one at a time, which can be kind of slow. You'll notice that we are able to draft these even with those rounds still attached. But what I would like to do is, kind of power select, find all those faces on the model. So if I just grab these 2 here and we go to our selection panel, this essentially takes what I've selected and searches the model for similar geometry. Things like coaxial surfaces and faces of the same area, which is what we're going to use here to quickly grab the rest of those holes. Then we can set up a draft plane on the bottom here, and I could either drag or just type in a number like 3, and we'll see that those have been drafted outwards at the 3 degrees of draft like we're seeing here. Now, I may, have some other types of faces to draft, like all of the ones on the outside. And there are a lot of different ones. There are all sorts of different shapes and sizes. And so we have all sorts of selection techniques. We have the power select here. We have a whole drop down of different types like lasso and boundary. But here I can use a box select across the middle of the model to essentially grab all the vertical faces. From here, we'll just go ahead and set up our draft. And you'll remember that, some were already 1 and some weren't. But if, here, if I go ahead and say that I want all of these faces to have 1 degree of draft, now they're all going to. And let's go ahead and see if this is true. So we could go back into our draft tool and set up the direction. And if we go ahead and change this to 1, here I'm going to 0.9, you'll see that it is drafted right up to there. And then at 1, that's where, it'll start to show a little of red and green. Some questions are coming in. What is SPACECLAIM mainly designed for? I just want to jump ahead to this question because it's such a good one. It's really designed for any geometry operations, whether you're designing something to just have a concept, whether you're designing something to manufacture, designing something to simulate. SPACECLAIM can create from scratch or take in any imported model and prep it for any of those operations. So SPACECLAIM is really a multi-purpose, all-purpose CAD modeling tool. So one of the next applications that I want to look at, we've taken a look at a number of 3D modeling applications, but we may want to, create a 3D model from an imported 2D. So here we could see there's a few different parts, there's an assembly, and essentially these imported curves are just like ones that are created in SPACECLAIM. SPACECLAIM does support layers, so if we want to do things like turn off dimensions or center lines, we could easily do that. And the only thing we need to do in order to turn this into 3D is have a surface to pull on. And so we want to fill in the curves and have a surface there. So if I just select the view I want to work with and fill it in, I now have these different areas. Now, if I know what the size is, like here it's 0.75, I could just go ahead, select the faces that I want, and type in the value. And now I've got this 3D model to work with. Now, this is true whether it's a simple extruded part or maybe a revolved part. Here, I essentially have this cross section, and it's really easy to take that and also fill that in. Now, I want to revolve this around, but not all of these faces are actually part of the model. I could start by selecting all of them, and these faces are not really part of it here. In fact, really, maybe I just want to take this face here and revolve it. So how might we revolve? We've seen that, pulling in a direction is like extruding. And we've seen that pulling about a face is drafting. Well, pulling around something is a revolve. So if I specify inside of my pull tool an axis to pull around, I could either dynamically drag, I could type in a number, there's a play button, and now we have, this 3D revolve body. We could go ahead and change some of the colors, and you'll see that there should have actually been some holes here, but it didn't quite fill in right. And we can clean up those curves, but sometimes it's now just easier to work with the 3D model. For example, I can pull in a new face, pull that new face into a hole, and this hole is just an eyeballed size, but I can easily reference it back to the sketch here to make that the exact right size. And you'll also notice that there were some cutouts here. I can do the same exact operation to get those cutouts added. Fill them in, select them, specify this as a revolve axis, and I know I need to do a cut. By default, it's going to add, like you can see, and I can just turn on cut, and now we've got those slots cut into the model there. So very easy to go from 2D to 3D, whether we're looking at a simple extrusion or a simple revolve, or we may have a scenario where a model is really built from a series of views. So I can fill in as many views as I want simultaneously, and then I can orient those views to each other. I can rotate and align so that they are positioned correctly so that I can use them to rebuild the model. Sometimes we may, create and add from one direction or cut from another direction. And, it looks like a 3D body, but here it's really just three faces. But essentially I've got, some through holes across. We could see here with the center line, and then, I've got this counterboard hole going down. So maybe what I'll do here is just select this whole face here, easily remove those holes from my selection, and pull that up to the other side. Now that black default color is a little dark, so we'll just go ahead and change that there. And what we have here is this solid body. And, we can see those holes going across right through there. And now we basically want to cut that counterbore. So these we could easily just pull, up to add or down to cut. And now we have that nice through hole through there. And these other faces, are representative of our counterbore. We want to cut those down to a certain height. Instead of measuring what this length is, I'll just go ahead and pull it up to and snap it right to that line from that side view. And now we have our, nice, clean, solid model with through holes from one direction, with a counterbore from another. And if there were more detail, it's just a matter of, filling and pulling and, recreating that from those different views, from those different perspectives. So now another type of data that we often see and want to manufacture may be sheet metal. We may want to use sheet metal for fixturing, or we are simply manufacturing it and we need to get a flat. We need to get an unfold so that we can cut out the profile and then bend and stamp and punch and press and everything like that. So, here, this was an imported step file. There's not a lot of intelligence in it, but within our sheet metal interface, which we partnered with a German press manufacturer to have, the best in class tools and, some high level expertise, we have this whole interface, and we can easily convert this imported model into an intelligent sheet metal body. Now, what do all these, colors mean? There's some blue, purple, and gray, and yellow. This is intelligent sheet metal. So if I just want to see what our flat pattern looks like, I could go ahead and unfold it. And I might want to, look at my unfold in parallel with the folded model. So I could easily set these up above each other here. And what I want to show first is, this is now our flat pattern. We can export this to DXF to cut it out, to punch, whatever. We use a K-factor value to calculate the size, but if you have a bend table, you could use that as well. And within this unfold, we capture different detail on layers. Like we have our bend lines in one direction on one layer, bend lines in the opposite direction on another layer, and bend dimensions as well. there's a layer for forms, and to have these things not show up on the cutting layer, but show up on the forms layer, we have a very easy identification tool. There's all sorts of geometric sheet metal detail that we can identify and make intelligent. And in this case, we want to do it to forms. It's all of these, cutouts and punches in the model here, and it intelligently finds them and automatically recognizes them. And at first, it disappears from the unfold, like where'd it go? But it's gone off of this first layer, which we'll use to cut the profile, and now they're located on the second layer. So very easy to export to DXF and use it for a variety of manufacturing operations. Now, it would be great if all sheet metal models provided to us could just be unfolded, like they were manufactured correctly. When they're like this, we can easily make changes. Like if a customer asks to change the location of a wall, we could easily, translate. If the angle needs to be changed, we can easily grab the move tool and rotate it in one direction or another. If one of these, reliefs is of the wrong type, we could easily go ahead and change it. We can change the dimensions of it. If it needs to be a different depth, we could go ahead and change all of those things. So if we need to optimize this model to be manufactured or change it per customer's request, we could do the work for them and not have to rely on them to change the model and send it back to us. Now, not all models have all the nice geometric detail needed to unfold. This looks more like a model that, might be machined or molded, maybe difficultly with inserts. And so we might want to convert this into sheet metal. So we just need to remove these rounds. And as we saw, it's really easy to do that by finding all of them in the model with the selection process, filling them in so we have these nice sharp edges. And then when we want to turn this into sheet metal and convert it, you'll notice it highlights those edges for me. Why is it doing that? Because if I go ahead and click on one of them, it automatically adds the type of junction I have set at the top. It automatically adds corner reliefs. And what's nice is I can do these in groups. I want bends all across the bottom, so I can go ahead and select all of them with a box, and now those all have bends. I also know that I want all of these to have bends, so I could, again, just quickly drag across them, and now these are all nice bends in order to unfold. I want these to not overlap, so I could go ahead and change to a different type, like a full overlap or a no overlap, and just drag a box around the rest in order to rip those two. Now, let's see if this thing will actually unfold. So we can see here that it doesn't. We've got some bends, but along the top, you'll see that it's still connected in certain areas. So again, we've tried to add in, tools to make different, sheet metal operations a lot easier. Like if we have this bend here and this is connected, they can't separate. So we want to split it. So this easy split tool just allows me to, grab a couple points there, and it adds the split that I need. While we're doing this, let's go ahead and put our unfold side to side to see, if these improvements are actually helping. So we'll go ahead and we'll create one more split up over here, and we can see this has actually unfolded. We'll just do this one more time on the side here. We'll go ahead and split from here to here. And you'll notice, as needed, it automatically extended the split across this junction. We'll go ahead and do the same thing on the other side. We'll split that right through there. And you'll notice that these are able to fold up now, but we still have a problem here, too many bends at a junction. So, I mentioned that these junctions aren't just colorful, so it looks nice, they're intelligent. If I go ahead and click on the one that we already have, I can choose from one of the other types. And as I do that, it now enables the model to unfold. So instead of having too many bends here, I could go ahead and play around with the junction configuration, trying out different scenarios in order to end at a nice flat unfoldable model. So, SPACECLAIM allows you to import geometry, repair it, create 3D for machining operations, for molding, casting, sheet metal. And the last one I want to talk about is 3D printing, additive manufacturing. Here we have a model and it's a scan, and we might want to go just scan to print, but with, a few things cleaned up. So just look how quickly I can auto fix this model from our facets tab. This is a whole set of tools designed to work with faceted data. It could be from a scan. It could be an in-process CAM export. You may want to fixture it after roughing out one side. And so those can be imported in. And, we have what we call hybrid modeling. I may want to scan this, make a few changes to it, clean up part of it, and then 3D print it. So, I can bring in the scan, I can heal it into a solid body, and then I can model on top of it, fitting geometry to it, adding, removing, basically modeling right on top. And if the goal here is to just have, a nice clean hole, maybe it's through, maybe it's to a certain depth, you'll notice that I could even dimension here, to the scan. So if I want this to be a certain distance from part of the scan, I can do that. And we have all sorts of different tools to modify. I can merge and subtract, do all sorts of different Booleans. And now, I've essentially, married, this hybrid modeling, CAD modeling to faceted modeling. And, the one last thing I might want to do on something like this is, make it quicker to print, reduce weight, reduce material, reduce cost, but make it stronger all at the same time. And so I can do that with our shell tool. It allows me to hollow it out and create an infill. I can, depending on the technology I'm using, I might want to just do like a triangular extrusion for FDM, or if I'm doing, SLA or something more advanced, I might want to use one of these lattice configurations. There's a dozen of them. Some are surface meshes, some are internal. So, on a model here like this, I could go ahead and, play around with the shape, the size, the spacing, depending on how dense I want it to be. And then, this automated tool is going to automatically hollow it out, automatically create that infill structure, reducing, time and cost. And we'll see here, we'll just go back into that cross section. Now I have a much stronger model for printing. And